All right. Let us begin. First with, of course, attendance. Let's do that. Boop. So please tell me that you're here, and I'll just leave this running as usual. But where we're going today is this is a programming lecture, so please go to scratch.mit.edu so we can go have fun there. Okay? Maybe it's saved in your web browser by now. But today is all about variables and conditionals, things called conditionals that are essentially the equivalent of asking questions in programming, which is something that is nice to have, okay? And a variable, when I talk about those, I just want you to think of them as boxes that hold things, like a box that has a certain name that like maybe holds 42, I don't know, maybe we call it X. That's what a variable is to computer scientists. So let us begin first with variables because that's the easier topic, okay? So yes, a variable is something that stores information for us so that we can use it later. We give a short little name to something that might be a very complicated value, okay? It's all meant to make our lives easier, just like we use variables in math, right? You don't have to write, you just say X instead of like the square root of some infinite series. So a variable is just a box. All right, so I can make a box called X and have it hold 1,234. That's fine. In Scratch, I'm going to show you the first variable that we're going to use. It's always called input because it gets input from the user. And that can be set to whatever the user gives us, like 42. And then we can just use input to get at whatever the user typed into us, which is perfect. That's quite nice. And then instead of writing 1,234 or asking the user to input what they input before again, we can just use these variable names for the rest of our program. That's the beauty of these variables. We can come along later and say, oh, what's the value of X plus 1? Doesn't that sound nice? We can come along later and say, what's the value of input times 2? That's beautiful because I don't have to remember those values. They're just stored away in a box. I can look them up. Okay, so if that makes enough sense, I'd like to give you a real example of that. So let's make a program that instead of saying hello world, let's have Scratch ask us, the user of the program. We are the writer of the program and also the user right now. We'll have Scratch ask us what our name is. Okay, we'll have Scratch do that, and a special variable. I think I was wrong when I said input. It's called answer. It's going to be saved away there. And then we can use it later to say, hello, your name. Isn't that nice? Okay, so let me build stuff up here. So we're about to make this program. And do I just want to make it first? Let's see. No, I want to get there. So when we ask the user for something, there's a special variable in Scratch. If you click Start Creating, let me just show it to you now. Dun, dun, dun. There it is. If you ask for something, that is down here. It might be in Control even, or Sensing. Yeah, there's this ask block. Ask what's your name and wait. And then there's a special variable called answer where the value that this gets from the user is saved. Okay, so if I run this block, it asks what your name is. Of course, you can change this to anything. And I type my name, and I can hit enter or hit the little check mark. And now I have this variable. It has been set to my name. So this is what happened in Scratch's memory. It's got a box called answer, and right now it's set to my name. And I can click that box to get at the current value. So see how it's set to my name right now. Isn't that nice? Could try it again, say my cat's name, and now it's saved to that. It always can be updated. This block will set this variable, we say. Okay, does that make enough sense? And we can use that, okay? I do want to get into something right now that is not very important for just what we're doing, but it will be later when we do math. So when we're getting information from the user, we can get different kinds of things, right? We can ask the user to type their name, in which case it's a bunch of text data. we shouldn't interpret it as like a number or anything. It's just a bunch of characters. That, in computer science lingo, is called a string, okay? It's a weird word. Just think of, like, I don't know, the string of beads that are on like a friendship bracelet. They're made of characters. That's what it's called. So my name that it's storing right now is just a bunch of characters. It's called a string. And there's a big, big difference between the string 1, 2, 3, which is the characters 1, 2, 3, and then the number 1, 2, 3. And I'll try and give you some examples of that. That won't really come up too much in Scratch, but when we get to Python, it really will. Okay, so just kind of think about that for now. Try and see if you can come up with the differences in your mind. And what I'd like to say first is that these variables, the difference, has to do with what's called a type. Variables have things called types, and those types tell us what we can do to them. If we have a number, we can like add numbers, right? We can multiply numbers, divide them. If we have strings, just a bunch of characters, we can like print them out to the screen. We can like join the two strings together to make a bigger string, like one is hello, one is Lawton, and bring them together. Now they say hello, Lawton. This will make more sense with an example, but the types tell us what we can do. So numbers, we can do number stuff, and strings, we can do string stuff, character stuff. Okay, so without any further ado, let's make this program. Let's make a program that asks what your name is and prints out hello plus your name here. Okay, let's do it. So normally these programs should start when we click the green flag. So it first asks us what our name is, and then it stores whatever we typed into the answer variable, and then we can use the answer variable inside of another block that prints things, like the say block. Say answer for 2 seconds, right? What's your name? Lawton. And so it says Lawton now for 2 seconds because it's going to say whatever the value of the answer variable holds. That's a key thing. Okay? So answer now is set to Lawton. Whee. There it goes. Does that make sense? But we wanted to say hello, comma, space, Lawton, exclamation point. So let's make that happen. All right? We can do string operations with what's called a join block. That joins together two strings. So if we go down to the operators, there is one called join, and here are some default values. If you click on it, it shows you what it's going to do. It's going to combine those two words. Secretly, there's a space right here. You can kind of see it. Apple space. Join that with banana. And so it builds up the bigger string, we call it, apple space banana. I want to do that same kind of thing with hello. Hello, comma, and then my name. Answer. Whatever answer holds. And so this is not yet correct because, sorry, it's so small. It's missing that space still, right? It's not that smart. It's going to say this. It's going to put these characters right next to whatever these characters are. And so if we want to separate anything, we better add a space in there. Hello, comma, space, Lawton. And so that's almost all the way there. If I rerun this program, the only thing that's missing is the exclamation point. And if we want that, we just have to join this big string, right, with an exclamation point at the end. So let's just bring out another join block. So join this with not banana, but an exclamation point. Does that make sense? So it's making a small string, and then we're combining that result with just a single character, exclamation point. And so it builds up exactly what we want to say. Does that make sense? Any questions about that? How that's working? Just a bunch of operations in this green section, and we'll get to a few of them. All right, so this is the full program. When the green flag is clicked, that starts the program. It asks what our name is and waits for us to type in and press enter or the checkbox. And then inside of that variable now holds whatever we typed. Could have been my name, could have been your name. And then finally, we want to print something. We want to say to the screen, want the Scratch Cat to talk to us, say this big long string. Combine hello with answer, whatever that is, and then after you've made that, put an exclamation point at the end of that. You see how that's working? Sorry, the screen isn't wide enough. I can zoom out, but then it gets harder to see. So, what's your name? Lawton. Stores Lawton and answer, joins them together, and says hello with an exclamation point at the end for 2 seconds. Yeah? Cool stuff, right? So that's string stuff. Let's do number stuff. Scratch doesn't really care about the difference. It'll convert one way or another. So let's make a program that gets the absolute value of what the user types. Let me first save this program so that I can give it to you later. Save, and then I'll make a new one. So when this program starts, we're going to ask the user for a number, and then what we want to do, because the user might type any number, right? They could type a positive number or a negative number, or 0. Maybe they typed negative 42, and we want to calculate the absolute value of that number and spit it back out, okay? That's a useful program to write. So we get any number, and we output the absolute value of it, yeah? So let's do that. And it looks like past me wants me to start the program in a different way. Let's make this program not start when the green flag is clicked, but when the sprite gets clicked. Why not? Delete. And that's when the scratch cat, if we click the scratch cat, then it'll start the program underneath here. That's kind of cool. All right. So just like last time, let's ask for something. Instead of what's your name, be like type a number. And wait, and then after we've typed that number, again, the answer variable is going to hold something. We can do stuff to that variable. We can calculate. There's a handy-dandy abs block. There's actually a bunch of different operations you can choose that are number stuff, like sine, cosine. But we have abs for absolute value. We can calculate the absolute value of whatever is in the answer variable. That's pretty cool. So we can just print that out. Say abs of answer for 2 seconds. It will calculate it for us. Isn't that nice? So it took whatever was in the answer variable, calculated the absolute value of it, and then set it for 2 seconds. And this program starts when the sprite is clicked, not the green flag. So I got to click the scratch cat to run it. Negative 42. That stores negative 42 inside of answer, right? The answer is negative 42, but if I take the absolute value of it, that computes positive 42. And I want to say that for 2 seconds. Okay? And again, if I click him again and type positive 42, he again says positive 42 because the absolute value doesn't change in that case. So we just did math. Yay. Any questions about this program? Make enough sense? Something very interesting is going on in that answer knows whether or not it's a number. That's going to maybe trip us up when we get to Python. We're going to have to do some conversion, but just enjoy this right now. So that is input. That is getting something from the user, putting it in an answer variable. Okay, so I'll save this program too. Are we ready to make variables that are not called answer? Of our very own. All right. So I would like to do one last one. So let's make our own variable, call it x. And then we can set it to whatever we want, okay? Let's make an x variable that increases whenever we press the space bar. That sounds cool. So we can start it with any value, 42, 0, it doesn't really matter. And then we're going to have that variable change by 1. There's a set block to set a variable to give it a value. I guess I chose 44 in this example. Let's just keep it there. And then we can show it to print it out. We can change the variable by 1, which adds 1 to it and makes it 45 instead. And then we can show it again. That shows the value one more time. Okay? So this is the program I'm going to write now. When the space key is pressed, because why not? That's another way to start the program. So let me make that work here. Delete, delete, delete. So when the space key is pressed, let us make a variable. Go down here to the variables block. There is one that's already made. You can make another, or you can rename this default one. Let's call it x. Bam. So now x can hold whatever I want it to hold. I can set it to 0, I could set it to 44. Doesn't matter. So if I click this to run the block, now x is set to 44. I can set it to something else, 45. Now x is set to 45. Pretty cool, right? So let's start it at 44. That makes when the program begins, x hold 44. I had it before up here. And then we can show the variable, which is kind of cool. That just prints it out, not coming out of the scratch-cats math, but just like up here in the top left. It shows that x is 45 because I didn't rerun it. So if I press the space key to run the program right now, it just prints 44 up there because sets x to 44, shows it. It hasn't changed. And then I can change that value of the variable, change x by 1, right? And that'll make it 45 because it adds 1. You can change it by -1 if you'd like to do something different to it. And then I can show it one more time. So what do we think this is going to print out when I run it? Take your bets. Dun, dun, dun. So press the space key. So it's going to show a 44 and then 45, right? Bam, bam, bam. It only shows 45. And what I'd like to teach you right now is how fast our computers are. It really is showing 44. It's trying to for a split second, but it's faster than the refresh rate on our screen. Okay? Our computer is that fast in adding a number and showing it and running all 4 of these blocks. So as humans, we only see 45. But inside the computer, it is making it 44 for a very split second. So if we wanted to see that 44, we should have waited for a little bit. Okay? Right here. If we wait for a tiny, tiny bit, then there is time to see this block run. It won't immediately run these two in like a nanosecond. Okay? Our computers are super fast. If we want to see something, we should make it wait. Let me show you that. That was it in sensing or was it in control? Wait a second. All right, so now we should see the value 44 for a second when I press space. There it is, 44 for 1 second. Then it changes it to 45 and shows the 45. Yay. Any questions about this program? It's a bit more complicated. So you set it to 44, and you changed it by 1? Yeah. And then did you show it after you changed it? Yeah. Yeah, something weird is happening. I'll take a look. Let's get it working. We have time. The weight is important. Okay. So I'll save this too. And I think we're good to go. So any questions before I get into something a bit different? Repetition or conditions. So one thing that I want to just point out about our programs right now is that they are all straight lines. So for example, we have something that starts our program. Oop, looks something like that, right? And then we put a bunch of blocks down, right? We got our A block that does thing A, our B block that does thing B, our C block that does thing C, and I don't know, a D block for good measure. That is what our programs look like right now, okay? And they run those blocks in order just like this. C, D, just like that. There are some things that you can't do with code that just looks like this. Let me show you the 2 other options. There's something called branching, which I'll talk about later today, and then there's something called looping, which I guess I'll give you a teaser just before we get into branching. So a branch looks like this. I start at A, but I have the possibility of doing either B or C, not both, and then maybe I come back to D at the end down here. So our programs can't have an option to take different routes. We don't have that yet. And then also, our programs can't do this yet. They can't come back to previous code and repeat themselves. That would also be nice to have. Okay? So these are 2 things that we will learn. Branching and looping. Let me show you just briefly an example of a loop. I'll make a program where we ask the scratch cat how fast we want him to spin. We type a number, and then we'll have the scratch cat repeatedly spin that many times at that speed. So this is an example of loops. There is a repeat block that takes blocks that go inside of it. Interesting. So let me write this code and then I'll explain it. So I guess when the up arrow is pressed, why not? Can I just delete all of this? I guess not. Okay, when up arrow is pressed, we can do different things to start the program. Let's ask the user, how fast should I spin? And that'll get stored in the answer variable. And this is going to be cute because there is a turn something degrees block. And here is him turning 15 degrees at a time. If we change this number, if we give a different number, he'll either go faster or slower, right? If he only turns 5 degrees at a time, it takes longer for him to get somewhere if you run the same block the same amount of times, right? So that is what we'll ask from the user and store and use to turn the scratch cat. So whatever answer was, we're going to turn that amount a certain number of times repeatedly, okay? So this is a repeat block. It repeats the inner code a certain number of times. So this is the number of times to repeat it. Number of times to repeat the inner code. And then whatever you put in here, it could be multiple blocks. It gets run that many times. So this block in particular will get run 10 times. Okay? And it will animate it. So repeat 10 times this, turn answer degrees. So if answer is a very small variable, it won't turn the scratch cat that much or that quickly. But if answer is a bigger variable, he'll move faster. Yeah? Does that sound cool? So it looks like this program starts when the up arrow is pressed. So I'm pressing the up arrow, spin 10. All right, that's your speed. There he goes. All right, let's try spin 5. That was slower. And he didn't spin as many times, or he didn't spin as far, right? Spin, I don't know, 30. Woo, there he goes. That was super fast. So this number, this whatever we put in answer, is going to be used to turn the scratch cat. And if we repeat that 10 times, there's just some default speed at which it runs that block. And the scratch cat is getting very dizzy. Any questions about this code? It's repetition. It's very nice to have so that we don't have to just put 10 of these, right? Otherwise, we would have had to make 10 of these same blocks if we wanted them to repeat 10 times and put them right next to each other. That's silly. No, we can use a repeat block instead. All right, so that's a loop. That's our first taste of loops. And now I want to talk about branches, if we're ready. Boop. All right. On to branches we go. So I want to talk about conditions and questions, because the way that we branch is usually we ask a question, because that's how we determine whether or not we go down the B side or the C side. Okay? That's what we want to do here. So, yeah, we want our programs to branch. We want our programs to do one thing or another depending on something, which is maybe different each time. So maybe like the input, whatever the user cares about. That's what we want to do. So maybe we can run something that looks like this, like check if the answer variable holds like 42 or something. And if the answer is yes to that question, I would like to do this first thing. Otherwise, if the answer is no, I'd like to do the second thing, something different. Yeah? And then maybe once I've had my choice of either of those, we can come back and then do the same straight line program down here. Okay? That's what we would like to have. Does that idea make sense? All right. So yes and no, we have already been introduced to. That's just true and false. All right. So special kinds of values that mean yes or no inside of a program are called Booleans, named after George Boole, of course. I say Boole for short. Booleans are values that are true or false. Okay, so if I tell you that I'm going to store a Boolean value inside of a variable, that variable is only ever going to hold true or false. Okay? And that is going to help us determine whether or not we want to run some code or some other code. Okay? So if we ask a question like, hey, is the answer variable less than 0? We're going to get back either true or false, because the because Scratch is going to try and test, hey, is the answer variable less than 0? Okay? We'd like to do something maybe if the question is true, and maybe something different if the question is false. All right? So let me show you one idea. Okay? Let's think about this. Let's think about how to calculate the absolute value without using the abs block. So we're going to roll our own abs block here. So I'm going to give you a question on this later to try yourself, but we're going to come up with the strategy first. So you have your answer variable, for example. If only I could spell answer. Maybe it holds negative 42 and we have to print positive 42 or something, or change it to be positive 42. So here's the kind of program that we would like to write. Here's how you can calculate the absolute value without the abs block. So we can get our input from the user, ask them for a number, and then we want to check, right? Because this is not the right answer to print out. It's not the same. If it's a negative number, we have to negate it, right? We have to multiply it by -1 to get a positive number. Yeah, there's two different options. So the first thing we'll do is check if the input is less than 0, because if it is, let's change it, right? If that's a true answer, if that's a yes answer, if that's true, then we want to multiply this by -1, right? Before we display it, before we print it out. Because that'll make it positive. That's what it means to do absolute value, right? So do that. And then after we've done that, we can display it, print it out to the screen. If this is not true, if this question has a false answer, then the input was either 0 or positive. We didn't have to touch it, right? There's no multiplication necessary. It's already a positive or 0 value. So in that case, we can just go straight to displaying the number. Display the number. Does everybody see how this is the correct absolute value calculating program? All right, that's what we want to make. How can we do it? So the secret lies in what's called an if-then-else block, okay? And this is in Scratch. You can drag one out. I guess. Can I delete everything?
You can drag it to the left. I'll delete everything.
To the left?
Where all the other blocks are.
Oh, thank you.
Yep.
Yay, now I know. All right, so it's right here, if then else. And let me tell you what it all means. So, stop this program though. What goes here, there's a little space here and it's hollowed out. It can only hold special things that calculate true or false. You notice how these look like different fitting blocks to these? So it's down here in operators where you can create stuff that gives back true or false. You see how that looks right? It could go in there, things like that. That's the right answer. So these are relations, things that can give back a yes or no answer. That's what goes there. And that's called a condition. Condition goes here. It must become true or false. It must be calculated eventually to true or false. True or false. All right? Because that will drive whether or not we run the code in here or the code in here. That's how it works. So let's call this 1, I don't know, and call this 2. So 1, this part, is executed if this condition was true. Okay? Executed if, I'll just call it cond for condition, is true. And this is called the true branch, we say. The true branch of the code. And this part gets executed if the cond is false. And this is, of course, then called the false branch. Yeah. So, in essence, you put your little condition as big as it needs to be. Whatever it's going to do is eventually compute true or false. If it's true, we run code 1. If it's false, we run code 2. Okay? Does that make sense how this is going to work? And so, what are some things that can compute true or false? Well, you can test variables. Like, all right, is answer greater than 50, for example? Do I have a number in answer right now? I have 30. Yes, cool. So 30 is apparently an answer right now from before. I can plug it into this block and click it to run it, and it calculates false, of course, because 30 is not greater than 50. Yeah. If I did it the other way, if I did is 50 greater than answer, because answer holds 30 right now, click it. Now it's true, right? It figured out the answer to that question, and it gave back true. So that would run the true branch. Okay? So you put something up here, and that drives whether or not you run the code in the if side, the true branch, or the stuff in the else side, the false branch. Okay? Any questions about how that's going to work? Do we think we can infer how to write the absolute value code now? Because that's my question for you. What I'd like you to do now that I've taught you all this stuff, I'll go back to this slide after I tell you your assignment, what I want you to do. I want you to take a little bit, help each other, and come up with, come up with the absolute value program, what I was writing before. Create the absolute value program without using the abs block. So get a number from the user, okay? Then test it, use this kind of if-then-else block to do this algorithm that we were talking about, to change a variable's value, things like that. How do you do that? That's down here in variables. You can change x, or you can set x to be x times -1. There's a multiplication block. It's this one. Put x in there, x times something. That's the kind of thing I want you to use there. That'll make it work. So yeah, I just want to give you guys plenty of time to play around with this, see if you can get it working, and then I'll show you my way of doing it, and then I'll introduce your next assignment, and we'll call it a day. Okay? So that is your my challenge for you. Okay? Does that make enough sense, this question? Make that absolute value program without using the abs block? All right, so get into your peer instruction groups, please. Help each other, work together, and I'll give you several minutes to try this, okay? Let me see if I can put all this information in one place for you. So like this bit, that's useful. I'll make it small, put it over here. This information, make it small, put it right here. And then please yell at me if you have questions. So give this a try, help each other. Let's start with 5 minutes. very rough tissue, I apologize, but yeah. Really didn't see any. Are we getting it?
Have you coded before?
A little bit. Java.
Ah. Are you a computer science major?
I'm trying to learn as much. There's this really fun game on Steam called Bit Runner. I think it's fun.
Are you taking CSCI?
Next week.
Then you're taking current industry. Set up so you start in the spring, you take Latin all the way through, and then you start in the fall, you take Kirby all the way through. That's pretty cool. My mom's actually in it. She's at 40 classes right now. Yeah.
Are you taking both, or are you taking
I'm taking CSCI 41 in Kirby and CSCI 1 in Latin. It's my last semester, so I'm just trying to figure everything. Yes, that's probably it. Because, I mean, we could make it into a function. One of the other tutors. We want to be really extra mathematical.
Was that enough time? Is anybody having a good discussion and wants to continue? Tell me. All right, I'll give you another couple minutes. Yeah, if you've already got it working though, here's my, and you haven't tried it this way, try this one. Try making a variable called x, whatever you want. Try putting your answer into x, and then changing x to be maybe times -1. And then in each of these cases, you can just display x because you would have changed. That's a new way to try it, maybe.
When you make block, how do you make it so that it returns a value?
What do you mean return value?
So how do you make it so that it will return the asset value of the number?
Oh, yes, you made a function. Gotcha. So that is.
I mean, if you don't know, I can just look, but if you're like, oh yeah, it's in here.
Can you do make a new block? It's possible that you have options. I don't know. I think maybe the answer would be to put your answer in a variable. Change a global variable and then just use that. But I think it might not be possible any other way because clicking a block doesn't ever give back a value, it just does something.
Exactly.
You want to make like an abs block, a little round block for yourself, and I don't know if that's possible. Only make blocky blocks. All right, so let's come back and discuss now. Now that we've had a few minutes trying all of this, let me show you this fancy way. Let's put the answer into X and work with X. But this is what we'll do. All right. And if you thought of something cool, tell me about it, and I can try it that way too. So, let's just go back to normal. Start the program when the green flag is clicked. So we're going to get a number from the user, right? We have to do that because otherwise the program runs the same way every time. We want it to be different. So enter a number, please. We don't want to like hard code the number. We want it to work for any number that the user types. So we're going to enter a number and wait, and then it's sitting in the answer variable, right? Whatever the user types, as usual, gets put into the answer variable. And I would like to work with the X variable instead. So I need to put whatever is an answer into X, okay? So I can just be like set X to answer, and now X holds the value of answer. That makes sense, right? It'll hold whatever X holds. So here's answer, negative 42. Here's X. It's going to hold whatever answer held. So I'm going to put negative 42 also into X. So that's what this block does right here, that first one. And then, oh man, I would like to branch. I'd like to do something different depending on whether or not input, which I'm calling X now, is less than 0. If it's negative, I want to do something special in addition to displaying the number, okay? So if answer is negative, so I need a less than block, not a greater than block. If answer is less than 0, then I want to do something special. I want to change it, right? Set X to be whatever it was. Oh, sorry, not answer, it's X. Because I'm working with X now. So if X is less than 0, I guess technically answer holds the same value. But if X is less than 0, then set X to be X times negative 1. Okay, that works. And then I could totally display X, say X for 2 seconds, right? Whatever its value is. It'll be positive, right? Because we've just changed it. We've set X to be whatever it used to be times negative 1. So that'll make it positive 42 in this particular negative case. All right, so that's that branch. And then otherwise, if it's positive, it's greater than or equal to 0, then we'll be in the else branch. And we don't have to touch the number. X is just what it is, and that's the right answer. So we can say X for 2 seconds again. Can I just duplicate this? Duplicate. Put it back. Okay? Is that kind of like what you got? That should do it. So enter number, negative 42. It's less than 0, so we're going to run the if branch. And it prints positive 42. Nice. If we print, I don't know, 12 or 0, then it just goes to the else branch because it's not negative. Okay? Any questions about this code? Yes?
What would be the difference if instead of X you just put answer greater or less than 0?
That would also work. The one thing I was trying to teach you was how to change a variable's value using the set block. That's the main difference. Or do you mean like this? It could have still been answer because I haven't changed the variable yet. Yes, I had another option. Yeah, it could have also been if answer is less than 0. But I kind of want to forget about answer after I've set X to be it. That was my intention at least. But yeah, either way would have worked. Good question. Any others? All right. One thing right now that we could make better is, does anybody see some unnecessary code? Could I do one thing and have fewer blocks in my program, yet the same answer? Still using X, though? Does anybody see it? Good, yeah, it's the say. That's being duplicated. Do I have to duplicate it? Where would I put it if I didn't duplicate it? Yeah, so this is how it could work. And in that case, I don't actually need an if else. Because I wasn't using the else at all. There's just an if part that only does stuff if something's true. So that's the one I could have used, and it gets rid of that. And now you see, like, only if it's negative negative do I need to change x? And either case, I'm going to save the value, the same value. Does that make sense? Yes, that's how you can fix that. Very good. So I think that is all I wanted to say there. Any last questions about this program? Of course, I'm going to give it to you. I'm saving it right now. I'll put it on Canvas. But that's a fancy program. All right. So, yeah, I think that's what I wanted to say. That is the meat of the lecture. I would like to give you plenty of time to start your next assignment now, though, your next programming assignment. So let me tell you all about it. It has to do with conditionals. So let me release it. Boop, programming assignment 1. Let's go to it. So I recorded a little introduction video if you want to watch that in a previous semester. But here's what I want you to do. And this is for the people who haven't programmed before again. Still, if you've programmed, I have a different exercise for you to do. So I'll get to that. So here is your program that I want you to write. I want you to teleport the scratch cat, okay, for this assignment. So I want your program to start when the scratch cat gets clicked. Okay, that's the first thing. Program should start when the scratch cat gets clicked. And then it should do the following. Okay, you should make the scratch cat appear magically somewhere on the screen. You don't technically have to hide him because there's just a move randomly. So let me change that very quickly. Make the sprite. It doesn't have to be the scratch cat. It could be whatever sprite you care about that's in your program. Make the sprite magically appear somewhere randomly on the screen, and there's a block for that, right? That's motion, go to random position, something like that, or glide to random position, one of those two. Boop. There he goes. He moves around randomly. So you'll use that. And then after you've moved your sprite of your choosing to a random spot, that sprite has coordinates, right? There's always coordinates relative to 0, 0, which is right in the middle of the screen. In that case, you want to test things now. I want you to figure out whether or not your sprite is above the middle of the screen, like the y equals 0 line, okay? So your sprite will magically teleport, right? And then there's this magical y equals 0 line. And if your sprite is above it, I want you to say something to that effect. I want you to output, I am above the line or something. I'm above the middle, whatever you want to say here. Doesn't matter, as long as it's something different. I'm above the line, the middle. Yay. If they randomly get teleported there. And if they get teleported below the y equals 0 line, I want you to have them output, I'm below the middle or something, just something that's different, okay? If they get magically teleported down there, I'm below the middle, or the y equals 0 line. Or you can make some fancy scenario having to do with whatever backdrop you choose, as long as you're testing this position of the sprite. You want to test this y coordinate. See how that's changing? It's positive if the sprite is above the y equals 0 line. It's, of course, negative if the sprite is below that line. And so I want you to test the y coordinate of the sprite. And oh man, can you access that somewhere? You can access the current coordinate of your sprite right here. Motion y position. That's the variable you'll need. So you'll test that. Ooh, it's negative, so I'm below the line. Ooh, it's positive, so I'm above the middle. Does that make sense? So just a cute little example to get you thinking about conditionals. And I think that's about it. So just follow these rules. Make it fun for yourself if you like. You could play sounds in Scratch. Have I showed you that yet? Or have you discovered it yet? That's one of these. Is it events? No. Is it control? It might be look sound, sorry. It's just sound. So there's like, you can have him meow whenever he teleports or something. Isn't that cute? And you can record your own cat meowing if you'd like to get extra credit. Nice. So that is something you could have fun with. So you have to use the following blocks, right? You can't hard code the random position. You have to use a block that contains the word random, and you have to use an if-else block, okay? Those are your requirements. And feel free to watch a video of me showing exactly how your program might look, okay? So that's what I want you to do there. And so feel free to get started on that if you have never programmed before, and that is your assignment in that case. If you have programmed before in a previous class or on your own, then I want you to read chapters 1.3 to 1.4 of that book that we were talking about last time, and then do exercise 5, okay? Record a video and explain what you're doing. Oh yeah, that's one last thing I want to say. To submit, I would like you to record yourself. Okay. Show me that you understand your program. I want you to record yourself talking about it. Run your program, tell me what's going on, okay? Upload a video, your program running with your code visible. It doesn't have to be long, okay? Record it however you want. You can use Zoom, you can use your phone, you can use OBS like I've been using here. I can help you. What? As long as you have your sound, your microphone is included, because I want to hear your voice. So that also works. Yeah. So I want you to upload a video of your program running. I think that's how we're going to do submissions for the rest of this class for your programming assignments. Okay. If you are unable this time to upload a video, I know this is kind of last minute, so I'm throwing this upon you. Then for this one, you can upload a screenshot and make sure your code is still visible. But in the future, I want you to upload a video. So get that working before the next assignment. Okay. Video recordings will be required next time. Yeah? No. Oh, goodness, no. This is due February 3rd. Yay. Program assignment 1, February 3rd. So that'll be next week on Thursday. Okay. So try to get that working. I can help you in class or in office hours to get a recording going. And then same for you programming people. Do exercise 5 and record a video of you getting the answer. Okay. Any questions about this assignment? Does that make sense? All right. I think I can officially stop the recording.